Hello, in this tutorial we will be solving this problem. This is a greedy problem and the problem name is partition labels. So given S of lower string letters, we want to partition the string into as many parts as possible, such that each letter only appears in its own part. So that's what it means when it says appears in at most one part. Return a list of integers representing the size of these parts. So you can see that they gave us an example here, this really long ass string, and these are the sizes of the partitions. And we can see that there are 3 partitions. In each of these partitions, the letter only appears in their own partition. So the letter A will only appear here, the letter E will only appear in this partition, and the letter H will only appear here. And they go on to say that a partition like this is incorrect because it splits S only to 2 parts. So we want as many partitions as we can get. Alright, cool. So the trick is we could do this in n squared time, but we can also do this in, say, just one single run or in on time. And that is, we are going to have to keep track of the last occurrence of each letter that appears in the string. So the idea is we are going to traverse the list backwards, and whenever we encounter a new letter, we are going to take note of that position of that letter. So we'll call that last. Alright, so now we're going to do for I in S reverse. We're going to need to keep track of, we're going to need some kind of counter. So we're going to need to get the length of S and then subtract that by L. Alright, let's see what last looks like. Awesome. So we can print it, we can't return it. Now my main concern is 24 doesn't actually exist in this, position 24 doesn't exist in this array. Because the length is 24, but to access parts we go from 0 to 23. We can fix this by starting this at 1. And there we go, and all the other letters are fixed. Alright, let's set up our answer array now. We're also going to keep track of our max last value. So when we encounter the letter A, and then say the next letter C, we want to take the max of the 2 last values. So if C's last value was 9, we would essentially search to the end of the string at C, and if no other last surpasses 9, then we know that we have a partition there. And since we need to keep track of their lengths, I'm going to do for I in range of length s. Which means I'll have to change this. Now what we are going to do here is we're just going to append the length of our partition. And there we go, we are very close. There's just some minor adjustments that we need to do. We could optimize this part, because technically when you call sum, it traverses through the whole array to calculate the sum. Instead, we could just keep, say, a variable called sum answer and increment whenever we append it to I. But for now, this is okay. And since that we're starting off at 1 here, for the first element, we will plus equal 1. And there we go. Alright, let's submit. Oh, I kind of already know it works. And for some reason, it became faster. I don't know why. Oh, God. Yeah, I don't know why it became faster. Anyway, thank you very much for watching.